in general, let's draw one. All right, I'm just doing a sketch here so we can label some vocabulary, okay? Maybe let's say we've got a parabola there, okay, obviously just hand sketched, so not the best possible thing it could. All right, we should hopefully at this point know that this is called the vertex, all right, and we can algebraically find that, all right? Every quadratic has an axis of symmetry, all right? It's the imaginary line, which means that the quadratic is reflected across that line. So that is your axis of symmetry. All right, as another vocab word. All right, now it needs to be dotted because the actual quadratic itself will be solid. This is a vertical line, so the equation of that axis of symmetry will be x equals and then at whatever number it is. So if I told you that right there was 4, then that axis of symmetry would be x equals 4 because that's the equation for the vertical line. All right, other things that we probably already know. Let's go ahead and write our general form, or our standard form rather, y equals ax squared plus bx plus c. All right, we've been working with this for quite a while now, so we know and look at that. We know what we're talking about. We've factored it, we've solved it, we've done a variety of things with it. Okay, the a coefficient. All right, that a coefficient. All right, this should be review for you. When a is less than 0 or negative, then the parabola is upside down. When a is greater than 0, then it's right side up. Okay, now we can be a little bit more specific about that. All right, if I want to take a look at, say, the absolute value of a, okay, if I look at the absolute value of a, then that also is going to indicate to me how wide or narrow it is. If we're just sketching, especially, that would come in handy. All right, so when the absolute value a is relatively small, that means that the quadratic is going to be fairly wide, okay? When the absolute value of a is a rather large number, or larger if I were comparing the 3, you know, if I had 3 different choices that I want to compare, then the quadratic then would be relatively narrow. All right, so that comes into play more when you are just sketching your graph or sketching the parabola as opposed to actually graphing it, but we will be graphing them. Okay, we will be graphing them. So I enter one more person in the Zoom meeting. All right, so let's go to some formulas after this. Let's have our axis of symmetry formula. So our axis of symmetry, oops, 2 N's, can be calculated by x equals a negative b over 2a. All right, so again, the a and the b is going to correspond to those coefficients that are in the equation. So let's write the equation one more time. And I could even do function notation. I don't always have to do y equals. I could do function notation. All right, ax squared plus bx plus c. So that a and b right there are the coefficients right there. So that's a formula that pretty sure needs to be memorized for the final exam. All right, now what you did when you were in high school to find the vertex, you probably did not memorize x equals. All right, you probably just memorized negative b over 2a. All right, that probably sounds familiar to you. So then you calculated that number and then you plugged it back into the function and it gave you the y value for your vertex. And in high school, maybe you were not given what that looks like, but the vertex is an ordered pair. So using math notation, I can actually say, okay, it's going to be an ordered pair and my x coordinate is negative b over 2a. It's the x coordinate because that formula is really x equals that part. Then I take that number and I plug it back into this function that's called f. Well, we've done enough work with functions this semester to know that, okay, to plug that back in, it's f of negative b over 2a. Being able to write it like this and recognize this notation means whatever this number is, I take it and plug it back in the function, and then that gives me my y value. All right, but so now in a college algebra textbook, you're going to see it written in that format. All right, so again, when it's in this form, let's put it down here, our y-intercept, okay, is going to be the ordered pair 0C every time, okay, but why? When I'm trying to find a y-intercept, I let x equals 0, okay, that's what I do. Well, if I let this x equals 0, this term goes to 0. If I let x equals 0 here, this term goes to 0. So these two terms fall out. So then my y-coordinate of that y-intercept has to be the value C right there. Okay, now we are going to, let's go ahead and put that in the box so I can put some more over here. We are going to calculate our x-intercepts as well. All right, now if I had a y-intercept and I was letting x equal 0, for my x-intercepts, I want to let y equal 0. All right, so even though I wrote this in function notation, I can replace this with a y. So this is y equals. All right, so in other words, then when you let y equal 0, that's right, let y equal 0. All right, then solve for x. All right, so just to see what that's going to look like, if I let y equal 0, I'll put a 0 there, and then I would have an ax squared plus a bx plus a c. All right, obviously with the a and the b and the c being numbers. And then this is what we've done over the last couple of sections. All right, how would we solve that? All right, well, we have some choices. We could try to factor and set everything equal to 0. We could complete the square, which you're probably not going to choose that method, but it's a possibility, complete the square. All right, we also went over just within the last couple of class sessions, we have went over the square root property where we took the square root of both sides. All right, and then last we did the quadratic formula. I'm just going to do QF there. We've done quadratic formula. So on the x-intercepts, it can end up being quite a bit of work. You set that equal to 0 and then you solve it, and it turns out to be a lot of work if you do have to use that quadratic formula. But these are the things that we are going to use to actually sketch or graph these functions. Okay, we will calculate that axis of symmetry. We'll calculate the vertex. We'll find some x-intercepts and some y-intercepts. All right, now with that being said, let's go ahead and do an example of that. Okay, so due to the fact that I'm not going to be using graph paper, I am going to say sketch. All right, on the final exam, we will give you a coordinate plane with an x and y axis so that you can actually graph it and be very precise on where you put those ordered pairs. So let's suppose we've got f of x is equal to a 3x squared plus a 12x plus an 8. All right. In this example, I'm just going to automatically go through everything that we just talked about on the final exam. It's going to be like part A, find the axis of symmetry. Part B, find the vertex. Part C, find the... So it's still going to step you through, so you don't necessarily need to memorize all of this. All right, so let's go ahead and switch here to a different color. Let's say that I am going to look for that axis of symmetry. Okay, so this is A, this is B, and this is C. All right, now you are going to have that formula memorized. So remember, it's x equals negative b over 2a. So that's going to be, in our case, negative 12 over a 2 times a. I'll go ahead and do 2 times 3 on that bottom so we can see it. Negative 12 over 6. That's going to give me a negative 2. All right. So if I had to write that as the equation of the vertical line, it's going to look like x equals negative 2. So when you write that axis of symmetry as your answer, again, just like we have done our asymptotes, we wrote them in the form of a line. Okay, so let's go ahead and draw our little sketch over here, because as soon as you start identifying things, then you can put things on your graph. All right, so here's negative 2, and I know that's my axis of symmetry, so I go ahead and put that dotted line in there. Okay, that's the first step. All right, now next thing, usually after you find that axis of symmetry, most logically the next thing then would be to find the vertex. All right, the vertex is that point, right? So I know that the x coordinate is -2, so I might as well go ahead and plug that in. That might even help you remember what you're supposed to do with that. But I am supposed to take that -2 and plug it into the function. So I'm going to actually use my function notation since the function is called f. All right, so then I'm going to go 3 times a -2 squared plus 12 times that -2 plus 8. So in other words, just a bunch of arithmetic there. All right, I'm not overly concerned with that. You can use your calculator. You can do that by hand. All right, that works out to be a -4. All right, so then this is my y value in that vertex. So it's a -4. All right, so then there is my vertex. Now, once I know where my vertex is, all right, my vertex had better land on that axis of symmetry, and it does. All right, so it's at -2 and then -4. All right, so this is the part where if I was actually on graph paper, then this would look definitely a lot better than what my hand sketch is going to look like right here. All right, now at this point, we know where that vertex is. We know that axis of symmetry. Okay, we could go ahead and just do a little bit of stuff that we know here. All right, our leading coefficient A there is a 3. It's positive, so that means it's going to be upright. And as you can see, that's going to fit really nicely on my graph right here. So it is going to be an upright one. All right, very quickly, I can do the y-intercept. All right, we said that was the 0C. All right, so order pair 0, and my C value is 8. So no math needed for the y-intercept when it's in this form. Okay, and so let's go ahead, and it should be on the y-axis. It will be on the y-axis. All right, rough count there of 8. Okay, and then your x-intercepts. That's the part that's going to take a little bit more work. Okay, so basically on this one, I can look at this. I mean, we could try to factor this. All right, but when I slide, if I would try slide and divide, 8 times 3 is going to be 24. And real quickly, I can see I'm not going to be able to get that middle term of 12. So since factoring is not going to work, then I would automatically go to quadratic formula. Okay, so we're going to set up that quadratic formula, and then I'm not going to actually work it out. We did that on Monday quite a bit. Okay, so our quadratic formula again should be x equals, all right, negative b, which is -12, plus or minus, all right, b squared would be 12 squared minus 4 times a times c, and then all over r2 times our a. Okay, this is again just basic arithmetic here. That'd be 144 minus whatever that's going to be. I'm pretty sure underneath that radical it turns out to be 48. So it's not going to come out to be nice numbers. All right, I'm going to have a -12 plus or minus the square root of 48, and then all over 6. All right, and we would have anticipated that this is going to be a decimal. Since this did not factor out nicely, then yeah, this is going to be a decimal. Okay, if I did the math, I'm going to let you do that on your own if you would like to actually work out that quadratic formula. All right, I got, as long as I didn't make a mistake, -0.84, and x is about then -3.15. Okay, so, and then if I wanted to write those as order pairs, I could, comma 0, comma 0. I'm not going to. I'm just going to do it like that. All right, now, if I want to sketch, as of right now, I only have 2 points. All right, plus my x-intercepts as rough estimates right here. All right, but if this is my axis of symmetry and I know that there's a point right here, then I know there is also a point. This would be 2 to the right and up 8. So 2 to the left and up 8 as well. There's another point for my, oops, that's a little low. All right, for my reflection there. Okay, if I wanted to estimate these, -0.84, that's going to be roughly right about in there, and -3.15, going to be roughly right in there. Okay, so you can then connect those, and hopefully, regardless, if you're on graph paper, it's going to look a little bit better here. I'm going to definitely try to make this look round down here because I know it's a parabola. Okay. So again, hand sketching, not wonderful there. But you are going to be expected to do this in its entirety on the final exam. All right, but the part is you will not have to memorize all this. They're going to lay this out. This will be like part A. They're going to tell you to find this. This will be part B. This will be part C. This will be part D. And then the graph will be at the end. And we will provide you with actual graph paper, okay, which is going to then make what you do a little bit neater on the final exam. All right, do we have any questions so far?